Welcome to this week's Business Transformation 101 podcast. I am your host, Bill Fegis. The monuments mentioned in the title of this podcast are not what most people would think of when they hear the word monument. The monuments in this podcast are not the Lincoln Memorial, the Martin Luther King Jr. Memorial, the Statue of Liberty, Mount Rushmore, the Vietnam Veterans Memorial, or other similar commemorative structures. Rather, the monuments discussed in this podcast are big, expensive, inflexible pieces of equipment or structures found in a process. The reason to hate, or at the very least strongly dislike these monuments, is they impede one-piece flow, flexibility, and agility. They effectively tie one hand behind your team's back when they are attempting to make transformational improvements. Monuments can be identified by their characteristics or by the type of equipment. They typically have some or all of the following characteristics. They're designed for batch processing. They require high levels of work in process or WIP inventory to operate effectively. They are physically large. They require special installation, for example, mounting on an isolated mounting pad or in a pit in the floor. They are difficult to move or relocate. They're expensive. They require long changeover times. They provide production throughput that significantly exceeds customer demand, and they are a shared resource serving multiple value streams. There are certain categories of equipment that are often monuments. For example, painting lines, finishing lines such as plating, anodizing, etc., coating lines, heat treat systems, or curing ovens. The team needs to look at the entire value stream when selecting equipment. In many cases, a monument machine looks great if the team is just considering the parts per hour the machine can produce. However, it does not look good when stepping back and viewing the entire value stream for the product, including the customer demand levels, the variability in the products that need to be produced, and the cadence of the variability. Sometimes there's a mindset to buy a super machine or monument to handle a process for multiple value streams. The analysis done with this approach typically excludes or understates the adverse impact that this will have on safety, quality, delivery cost, inventory, and productivity, in addition to flow. Avoid this shared super machine mindset whenever possible. One downside to a super machine is that many times it is set up to provide a process for all the value streams in a plant. If the machine goes offline for repair or unscheduled maintenance, the entire plant grinds to a halt. Utilizing multiple smaller machines rather than a super machine provides redundancy and flexibility. Another downside to a super machine occurs when customer demand exceeds the capacity of the super machine. At this point, another super machine is added, which has all the disadvantages of the original super machine, but also requires an investment that will be lightly utilized initially, since it is only handling the incremental demand. Until customer demand ramps up significantly, the investment is being underutilized. Procuring smaller machines adds capacity incrementally rather than in a big slug. If a monument cannot be avoided, buy a mini monument that is sized as small as possible to meet the current customer demand, and add additional mini monuments as demand expands. Many times the team must live with a monument since it is either prohibitively expensive to replace the monument, there is no one-piece flow replacement available for the monument, or there are no engineering resources available to design the monument process out. In this situation, the team should design a curtain process so the monument looks like a one-piece flow process to the operators. This allows the remainder of the process to be one-piece flow and fit the curtain to monument process into that one-piece flow. A curtain is implemented by utilizing standard WIP or work in process inventory. For example, assume the value stream has a 10-minute cure process and the takt time for the value stream is 60 seconds. The team would calculate a 10-piece batch size for the oven based on a 10-minute cure or 600-second cure time divided by the 60-second takt time. An additional 10 pieces of standard WIP is also needed to implement the curtain. The curtain process in this example would operate in the following manner. The process upstream from the curtain is producing a component every 60 seconds to meet takt time. These components are placed in a bin at the input to the cure process. Simultaneously, a batch of 10 components is in the oven curing. After 10 minutes, the cure input bin is full with 10 components, and the batch in the oven has cured for 10 minutes. The operator removes the cured bin of 10 from the oven and places it at the input of the downstream process. They place an empty bin at the cure input and move the full cure input bin of 10 components into the oven. The upstream process continues to place a component in the cure input bin every 60 seconds, while a downstream process removes a component from the cured bin of components every 60 seconds. After 10 minutes, the downstream process has consumed the 10 components in the cured bin, and the upstream process has filled the current input bin with 10 components. The operator repeats the process of unloading the cured bin from the oven and loading the full cure input bin into the oven. To the upstream and downstream processes, the Monument cure process looks like one-piece flow due to the current process and the standard WIP of 20 components. To avoid monuments and the need to implement curtains, the organization needs to recognize the waste and barrier to flow that monuments create. Design and process engineering must be charged with avoiding the need for monument processes wherever possible. The product preparation process, or 3P, can be used to implement new designs since it explicitly addresses avoiding monuments. The company's phase gate development process should include guidelines and checklists at the appropriate gate reviews to eliminate or minimize the requirement for monument processes. The standard work for the capital expenditure approval process should address the procurement of monuments also. A simple approach is to include a standard checklist as part of the CapEx approval process. This checklist could also be used in the phase gate development process. Here are some example items to include on such a checklist. First, machine capability should be matched to takt time. The machine should only have the functions needed to implement the process. Avoid bell and whistle features. Take the KISS or keep it small and simple approach. The machine should be designed for quick changeovers, that is, takt time or less. SMED, single minute exchange of die, should be designed in. Reliable, simple, quick change tooling should be used to maximize external setup and minimize machine changeover time. The CapEx request should include any added equipment needed to support maximizing external changeover time, for example, a second set of tooling or fixturing. The machine should be TPM or total productive maintenance friendly. That is, it should utilize standard plug-and-play components, especially controls such as PLCs if possible. It should be durable and have accessible maintenance points such as grease fittings. The business should standardize the brands and the models of its equipment to minimize spare components, training of operators, and training of maintenance personnel. Whenever possible, you should procure modular, reconfigurable machines to maximize flexibility. The machine should have a townhouse aspect ratio rather than a ranch house aspect ratio. That is, the load-unload portion of the machine should be narrow, not wide, to ease the design of a cell. If the machine produces chips and or scrap, they should be routed out the back of the machine to allow a material handler to service the chips or scrap and not interfere with the operators. Built-in andon lights should be included to visually communicate abnormal machine conditions. The machine should maximize poka-yoke or mistake proofing to minimize errors. The machine should also incorporate simple manual loading and automatic unloading if possible. To ensure safety, the machine should have all the appropriate guarding that meets or exceeds ANSI or OSHA safety standards. Any safety switches or interlocks should prevent easy bypassing. Ensure the machine has good ergonomics. Choose a design that optimizes the operator work height and eliminates or minimizes bending, twisting, lifting, or repetitive motion. Pay particular attention to the ergonomics of material handling. Note that this checklist includes safety and ergonomic items which are aimed at ensuring the machine is designed to protect operators from injury. It also includes items that will improve quality, cost, and flow. For a great example of the downside to monuments, see the, quote, monuments, unquote, section of the book, Lean Thinking, Banish Waste and Create Wealth in Your Corporation, by James Womack and Daniel Jones. This section of their book describes the $80 million turbine blade manufacturing process monument installed in the late 1980s by Pratt & Whitney and some of the issues it caused. Eliminating the monument reduced throughput time from 10 days to 75 minutes while cutting the cost of blade grinding by 50%. This is a great example of why monuments should be avoided at all costs. In summary, monuments can be a significant impediment to lean transformation. The short-term solution is to utilize standard work in process inventory to produce a curtain around the monument so that it effectively looks like a one-piece flow process to the upstream and downstream processes. Longer term, the business should ensure the product design and process engineers have guidelines to avoid the need for monuments and should utilize the product preparation or 3P process when developing new products. The business should create a capital expenditure process that eliminates the acquisition of monuments while ensuring the equipment is safe, ergonomically friendly, flexible, compatible with cellular production, allows changeover within takt time or less, and supports a one-piece flow process. In some cases, the business may elect to design and/or build equipment that meets these needs if an acceptable product cannot be procured in the marketplace or equipment vendors are not willing to address these requirements. If buying a monument is unavoidable, the team should acquire the simplest, most reliable machine that has a capacity that matches the current customer demand of the value stream, not the entire plant. In the interest of continuous improvement, I invite feedback from our listeners. Please share your thoughts and ideas on these weekly podcasts and feel free to suggest topics which you believe would provide useful information for you and our listeners. Thank you for joining us for today's podcast, and please join us next week for our podcast with Mark DeLuzio discussing his book Flatlined, Why Lean Transformation Fails and What to Do About It.